Hello out there. Welcome to the special 420 Zombie Messiah Devil Bunny edition of the No Shit Cast. I'm your host, Matt Frazier. Had a really cool freaking day today so happy holidays for everyone that's practicing a holiday this weekend, whoever you may be. But I had a really great 420 today, I guess, for lack of a better term. But anybody that's been following me here, I've talked about this a couple times at the mixing board and stuff that I had for the show. Took a shit, quit working, and today I had Anthony Hamalainen and his wife Anna over. Anthony from Armageddon and the new band Daughter Chaos. And I had Kenny Schaefer from Thought Dump Podcast over today. Well, and they were all helping me kind of work on the studio and get things put back together. So if you can't tell, I'm back up and running, new mixer, everything installed, configured, and working. Thanks. Huge shout out to Kenny Schaefer and Thought Dump Podcast for the hookup, setting me up with a temporary board and stuff here so that I can keep doing what I love to do. So it was a great day. We got to hang out a bunch, and then after that, I ended up on the phone with Sherfu Ramon Cariaga, who is going to be. We're going to be doing a podcast tomorrow, 421, if you will, about all the implications that a lot of this new black hole data that's come out and the images and stuff has had, and what it all means as far as electric universe and plasma cosmology. And stuff like that, how it kind of all fits together and what it supports. So should be a great show there, folks, coming up here tomorrow. So we'll kick it off here. This is an article from NBC News. Why alien megastructures may hold key to making contact with extraterrestrials. If you're trying to come up with the best game plan for proving the existence of extraterrestrials, you got plenty of options. Naturally, you want a strategy with a high chance of success, simply in the interest of time, money, and a shot at that Nobel Prize. For nearly 70 years, the scheme favored by most scientists has been looking for signals or radio transmissions. That's the classic approach of SETI, the search for extraterrestrial intelligence, and frankly, it makes sense. Radio can easily traverse light years, and technology for detecting it is well known and highly sensitive. But is looking for signals really the best plan? Is it possible that we're making the wrong bet? There's an attractive alternative, searching for physical artifacts, alien structures. We're not talking about crop circles here, folks, or other odd phenomena here on Earth. We're talking about massive engineering works that an advanced society has constructed somewhere in space. Why search for artifacts? Because it eliminates the requirement that aliens have chosen to get in touch or to transmit radio signals our way. Sure, maybe they'd want to do that, but then again, maybe they'd rather lay low. If you're not sure you're in the Milky Way's top dog society, you don't want to bet the farm by assuming that the alpha aliens, wherever they might be, have good intentions, since silence could have survival value. Yeah, boy, I wish it worked that way in politics. There's another point. Picking up an alien civilization's transmission requires that signals reach your telescope at the very moment that you're pointing it in their direction. This is SETI's well-known synchronicity problem, and it's been likened to firing a bullet and expecting that it will intercept head-on another bullet shot by someone else, and it's very improbable. In nearly every radio SETI experiment, the amount of time spent listening to any given frequency is but a few minutes. The universe has been around for nearly 10,000 trillion minutes. So SETI's efforts are a bit like stepping into the backyard hoping you're just in time to catch a raccoon stealing the cat food. Of course, you can believe the aliens have some good reason to spend lots of time transmitting to Earth. But if they're even a short distance away, astronomically speaking, they won't know we're here. There hasn't been enough time for our radar and television signals to reach them yet, even at the speed of light. In contrast, artifacts may be lurking in space just waiting for our discovery. All night, every night, China's Great Wall and Egyptian pyramids are earthly constructs that have existed for centuries. Finding them doesn't demand much synchronicity. Have we found any alien megastructures? In 2015, astronomer Tabitha Boyajian and her colleagues reported on a star 1,400 light years away that occasionally dimmed. Actually, it dimmed a lot, and this wasn't normal stellar behavior. One explanation was that the star was surrounded by a, quote, Dyson sphere. The idea proposed years ago by physicist Freeman Dyson is that really advanced aliens would construct gargantuan spherical swarm of solar panels in orbit beyond their own planet, sort of the way you might cup your hands around a candle to collect the heat. The swarm would gather enough starlight to energize the aliens' souped-up lifestyles and could sometimes get in the way of light from the star, causing it to intermittently dim as seen from afar. That explanation for Tabby's star seems less likely today. Astronomical measurements show that it gets redder when it dims, suggesting that it's surrounded by naturally produced dust, not a gargantuan group of light collectors. But it's reasonable to believe that Dyson spheres exist somewhere. In the past, astronomers looked for clues to such massive engineering projects by trawling star catalogs for systems that show an excess of infrared light, produced by the warm backside of the panels. Another approach is to comb through data from the European Space Agency's Gaia Space Telescope to find stars whose light is fainter than expected, simply because their shine is partially or constantly blocked by a bunch of panels. Recently, University of Chicago physicist Daniel Hooper offered a new idea for searching for high-tech alien artifacts. He notes that the universe is expanding and galaxies are growing ever farther apart. So forward-thinking alien societies might want to grab stars from nearby galaxies while they can and park them in their cosmic neighborhoods as a hedge against future energy scarcity. This is akin to storing gasoline if you're worried about a developing shortage. If collections of corralled stars do exist, they'd be easy to spot in the course of the mainstream astronomy research. I'm just trying to figure out how you corral a star. That's a big-ass, really interesting lasso. Looking for extraterrestrial signals has a venerable history and no doubt a promising future, but a search for structures accumulated during the many billions of years of cosmic time might give someone a leg up on that Nobel. Yes, efforts to find Dyson spheres has come up empty, and we haven't found any stellar stockpiles either, but tomorrow could be different. I don't know. I think it's kind of a neat idea. I mean, I suppose if you think about what an almost limitless advanced society would be capable of, maybe lassoing stars and dragging them across the cosmos somehow is feasible, but I don't know, given that we can't really even figure out how to travel past the speed of light. So that seems like it'd be a massive undertaking. This comes from Live Science. This quantum computer can see the future, all 16 of them, which is what intrigued the hell out of me. I was like, what do they mean by all 16 of them? So when Mile Gu boots up his new, that's M-I-L-E, Mile Gu boots up his new computer, he can see the future, at least 16 possible versions of it, all at the same time. Gu, an assistant professor of physics at Nanyang Technological University in Singapore, works in quantum computing. This branch of science uses the weird laws that govern the universe's smallest particle to help computers calculate more efficiently. Unlike classic computers, which store information as bits, binary digits of either zeros or ones, quantum computers code information into quantum bits, or qubits. These subatomic particles, thanks to the weird laws of quantum mechanics, can exist in a superposition of two different states at the same time. Interesting, huh? Just as Schrodinger's hypothetical cat was simultaneously dead and alive, until someone opened the box, a qubit is in a superposition, can equal both 0 and 1 until it's measured. Storing multiple different outcomes into a single qubit could have a ton of memory compared to traditional computers, especially when it comes to making complicated predictions. In a study published April 9th in the journal Nature's Communications, Gu and his colleagues demonstrated this idea using a new quantum simulator that can predict the outcomes of 16 different futures, the equivalent of, say, flipping a coin 4 times in a row, in a quantum superposition. These possible futures were encoded in a single photon, a quantum particle of light, which moved down multiple paths simultaneously while passing through several sensors. Then the researchers went one step further, firing 2 photons side by side and tracking how each photon's potential futures diverged under slightly different conditions. Quote, It's sort of like Doctor Strange in the Avenger Infinity War movie, Goo told Live Science. Before a climatic battle in that film, the clairvoyant doctor looks forward in time to see 14 million different futures, hoping to find the one where the heroes defeat the big bad guy. He does a combined computation of all the possibilities to say, okay, if I change my decision in this small way, how much will the future change? This is the direction our simulation is moving forwards to. The researchers tested their quantum prediction engine using a classic model called the perturbed coin. Oh, poor coin. Imagine there's a box and inside it is a single coin, Goose said. At each step of the process, someone shakes the box a little bit so the coin has a small probability of flipping. Unlike a traditional coin toss in which the outcome always has an equal chance of being either heads or tails, the outcome of each perturbed coin toss depends on the state of the coin was in during the previous step. If the coin flipped from heads to tails during the third shake of the box, for example, then the fourth shake of the box would likely remain tails. The researchers ran two different versions of the coin experiment, one in which the box was jiggled a little more strongly and another with weaker jiggles. In each experiment, the box was jiggled 4 times, providing 16 possible combinations of heads and tails. Following the fourth step, the team encoded it's the superposition of all 16 in a single photon simultaneously, showing the probability of every possible outcome based on the strength with which the box was shaken. Finally, the team combined the superpositions of the strongly shaken coin and the weakly shaken coin to create one master map of possible futures. This showed us how quickly the futures diverged depending on how hard I shook the box at each step, Goose said. Right now, constraints on computing power mean that the team's simulator can only look at 16 possible futures at once. One day, however, as quantum computers become larger, more powerful, and more commonplace, simulators like this one could be expanded to see infinitely many futures at once, Goose said. This could aid in things like weather prediction or making more informed investments in the stock market. Oh, goody. It could even help improve machine learning. We got to get the machine smarter, which is all about artificial intelligence teaching itself to make better and better predictions. This is all highly exploratory, Goo added, and will require a lot of further experimentation to figure out all the quantum simulator's applications. Alas, this clairvoyant computer's own destiny is one that may remain a mystery. Well, it's really freaking interesting what's going on there, but yeah, it's a little creepy. It's, when the machines start to learn things on their own, do they finally learn that we're like a parasite upon the planet and just decide to get rid of all of us? I don't know. Only time will tell. All right, this one comes from Gizmodo. The worst thing about Instagram might be finally going away. Yay! The only good social network is evidently toying with the idea of purging the worst thing about social media, and I, for one, couldn't be more on board. Spotted by Jane Munchin Wong and reported by TechCrunch on Thursday, an Instagram prototype gave us a glimpse at what I believe is a great solution to keeping the platform pleasant. According to TechCrunch, Wong discovered a test for the tweak to Android's code and generated an image for the prototype. In that image shared by Wong to Twitter, Instagram states that it wants users to, quote, followers to focus on what you share, not how many likes your posts get. During this test, only the person who shared a post will see the total number of likes it gets. Basically, per the screenshot, folks can still like your posts, but only you can see what your like figures are. This seems great for virtually everyone involved, every involved party, Instagram included. I mean, wouldn't it be great to post like no one's sizing up your likes? Might you, as TechCrunch suggested, be compelled to post more? At a time when being on social media increasingly feels like it borders on masochism, and boy, isn't that the freaking truth. This prototype tweak seems like a reasonable solution to maintaining Instagram's appeal as a corner of the internet that is still pretty tolerable and at times even enjoyable. I'm looking at you, stories. Sadly, it appears at present that this utopian, invisible, filled Instagram prototype is currently just that. An Instagram spokesman told TechCrunch that the platform is not testing this at the moment, but exploring ways to reduce pressure on Instagram is something we're always thinking about. I'm certainly of the mind that any way we can make logging on anywhere feel less like being crushed under a metric ton of vitriolic bullshit is probably worth exploring, but particularly on Instagram where things can still be nice and good, killing viewable feels like an especially worthwhile solution. Hello, Instagram. Can you hear me? Is this thing on? Listen, I'm telling you this now. This is the way. Pull the plug and save us from ourselves. Oh, boy, isn't that the truth? Yeah, because if other people couldn't see how many likes your post was getting, if you were the only one that could see how many likes your post was getting, it takes out sort of a weird kind of, popularity contest sort of vibe that ends up there a lot. So I actually think that's a really good idea. I really do. I think I'm on board with that. Here's one. Why lightning often strikes twice. This is from No Ridge Science Report. And, if you've ever been told, well, lightning never strikes twice, apparently that's bullshit. In a new study, researchers have found out why lightning often strikes twice. The research was conducted by an international research team led by the University of Groningen. Oh, I'll bet Sherfu's going to have some stuff to talk about on this. The team used the LOFAR radio telescope to study the development of lightning flashes in unprecedented detail. LOFAR is a Dutch radio telescope consisting of thousands of antennas spread over northern Europe. These antennas are connected with a central computer, and they can operate as a single entity. The goal of LOFAR is to help with radio astronomy observations, but the frequency range of the antennas also makes it ideal for dealing with lightning research. In the study, the team used the Dutch LOFAR stations to do their lightning observations. They analyzed the raw time traces measured in 30 to 80 megahertz band. They developed a new algorithm for LOFAR's data to visualize the radio transmissions from two lightning flashes. The researchers found that the negative charges inside a thundercloud are not discharged all in a single flash, but are in part stored alongside the leader channel at interruptions at structures that the researchers call needles. This may lead to a repeated discharge to the ground. The researchers suggested that these needles are hard to be seen by other lightning detection systems because they are too small and too short-lived. They suggest that these results clearly show that the reason why lightning will strike in the same area repeatedly. The high-resolution observations help them to solve the puzzle. One author of the study of Olaf Scholten, professor of physics at KVI Kart Institute in the University of Groningen. Yeah, it's kind of like a weird sort of capacitive thing, at least the way I kind of interpret that. I guess it kind of makes sense. So it like pops twice. But it happens so fast you don't realize it. It like the human eye can't detect it. It's too quick. Okay, so couldn't do a podcast without some news on my homeboy Elon Musk. This is from Florida Today. A SpaceX Dragon capsule suffered an anomaly during an engine test firing at Cape Canaveral Air Force Station Saturday afternoon. Company and the 45th Space Wing officials confirmed. On April 20th, 2019, an anomaly occurred at Cape Canaveral Air Force Station during the Dragon 2 static test fire. Wing spokesman Jim Williams told Florida Today the anomaly was contained and there were no injuries. Oh, good for that. Photographer Craig Bailey, covering a surf test in Cocoa Beach, captured an image of orange plumes rising from the SpaceX facilities at the Cape around 3:30 p.m. Unconfirmed reports indicate the capsule was nearly destroyed. Earlier today, SpaceX conducted a series of engine tests on a Crew Dragon test vehicle on our test stand at the landing zone in Cape Canaveral, Florida, SpaceX said in a statement. The initial test completed successfully, but the final test resulted in an anomaly on the test stand. Well, yeah, when you burn something up, that tends to be the final test. Maybe it wasn't the scheduled final test. Quote, ensuring that our systems meet rigorous safety standards and detecting anomalies like this prior to the flight are the main reasons why we test. Our teams are investigating and working closely with our NASA partners. That's right, folks. You got to stress shit and break it to figure out where it's going to break. SpaceX's crew, that's why, by the way, he shot his freaking car into space first. And I remember everybody getting all bent out of shape. And it's like, okay, would you rather he put like a $2 billion communication satellite on the tip of this thing and fire it up and go, oops, it doesn't work real well. And we just blew up this massive satellite. So, yeah, you got to do this kind of stuff. You got to test things and break them. This is not necessarily even that unusual. But more good news came out for our boy Elon Musk today. Tesla announces that 4 board members are going to leave. On Friday evening, Tesla announced that 4 board members are going to leave at the end of their terms this year and in 2020. With the release of Tesla's preliminary proxy statement for its upcoming shareholders meeting, The automaker made the announcement that the board members, Brad Buss, Antonio Gracias, Stephen Jurvetson, and Linda Johnson Rice will all not stand for re-election at the end of their current terms. Tesla says that the goal is to implement a, quote, phased streamlining of the size of the board to allow it to operate more nimbly and efficiently while maintaining new ideas, expertise, and experiences on the board. They described the phased streamlining in as filling. Quote, as a result of the April 18th, 2019, each of us and the aforementioned people agreed collectively with the board, its nominating and corporate governance committee, that each of them would not stand for re-election to the board at the expiration of their respective terms, which will be at the 2019 annual meeting of the stockholders for Mr. Buss and Ms. Rice, at the 2020 annual meeting of stockholders for Mr. Jurvetson, and for stockholders, and if our stockholders approve a director term reduction proposal as described in the preliminary proxy statement for Mr. Gracias. If our stockholders do not approve such proposal, Mr. Gracias' term will end at the 2021 annual meeting of stockholders. Such agreements did not result from any disagreement between Tesla and any of such directors. I guess I believe that. I don't know. It certainly gives him more control. Well, I think it does. A smaller board is less people to vote against you, but it's also less people to vote for you. So maybe it doesn't. But good luck out there, Mr. Musk. I hope it works out, man. I definitely dig what you do, and I wish there were more science ballers in the world like you, brother. This is from The Independent. The fibula, bone thought to be lost to evolution, mysteriously returning to the human body. What the hell does that mean? We are taught that the human skeleton contains 206 bones, but our study challenges this. A primordial bone found in our primate ancestors, but thought to be redundant and rapidly dwindling in humans, appears to have made quite a comeback over the past century. Scientists from the Imperial College of London have admitted they are stumped as to why the fabula, F-A-B-E-L-L-A, I said fibula earlier, but that's not it, a small bone buried in a tendon behind the knee, is now 3 times more common than it was in the early 1900s. It's because more people were doing jujitsu. I'm making that up. They speculate that its reemergence could be linked to joint problems, and understanding why could help treat and protect those most at risk. Why we don't know what the fibula's function is. Nobody has ever looked into it, lead author Dr. Michael Bertham said. We are taught that the human skeleton contains 206 bones, but our study challenges this. The fibula is a bone that has no apparent function and causes pain and discomfort to some, and might require removal if it causes problems. People with osteoarthritis of the knee are twice as likely to have a fibula, and its presence can interfere with joint operations, but it's not clear if the tiny bone is the cause or a symptom of joint problems. See, here it is, folks. We are reverse evolving. That's all it is. Yep, we've reached our panacea. We're going to create artificial intelligence. It's going to replace us, and we're going to devolve and disappear. That's what this means. This is the first, I'm telling you, it's the first sign of the apocalypse. So that's the final story, folks. Big shout out again. Thanks a lot to Kenny and Anthony and everybody. Thanks to everybody out there for just helping turn this podcast into, the cranking success that it's turned into now. And we've got a lot of really great content coming up for you. A lot of great interviews that are stacking up. And so just stay tuned, folks. Some really cool shit's about to drop here. I promise you that. So keep hitting them like and subscribe buttons. Check us out at noshitcast.com. It's KNOWSHITCAST.com. And we'll catch you all next time. Thanks for listening, folks. Bye.